Hello guys. All right. So, I am going to be skipping a couple of pages. I did not like certain pages, so I am going to be skipping 24. So we're not doing 24. As you can see, there's a big ol' X on there. Same thing with 25. We're not doing page 25. Bad 25. But we are going to be doing page 26. So let's do page 26. Page 26 and 27 is going to be all me. I'm actually going to do a little bit of page 28, and then you guys are going to be responsible for doing a couple of other ones. So for page 26, I'm going to be doing these. So doc, and then you guys will be responsible for the last two. So homework and homework. So examples 3 and 4, you guys will do. So on the top of page 26, what is the solution of a linear inequality? So we're talking about inequalities. That's the Pac-Man. So a solution of a linear inequality is anything in the shaded area, or another way to figure it out is when you plug in a point and solve, the inequality is a true statement. True statement. Meaning 0 is greater than -2, or 5 is less than 10, stuff like that. All right. So for instance, if we look at this first example, tell whether the ordered pair -2, 4 is the solution to the inequality y is less than 2x plus 1. So what are we going to do? All we're going to do is we're going to substitute in our point. So this is our x and this is our y. So instead of a y, I'm going to substitute in a 4 is less than 2 times -2 is our x plus 1. So 2 times -2 is -4 plus 1. So 4 is less than, I owe you $4 and I give you 1, is -3. Is 4 less than 3? Remember, if you can't figure it out, Pac-Man eats the bigger one. So is Pac-Man eating the bigger one? No, it's not. So no, because it isn't true that 4 is less than -3. All right, and that's it. So look at example 2. Tell whether the ordered pair is a solution of the inequality. So again, we're given another pair. This is my x, this is my y. So instead of y, I'm going to plug in a 1 or substitute. I have a greater than symbol this time. X is 3, -4. So 1 is greater than. I have $3, but I want to spend 4, so I need $1 more. So is this true? 1 is greater than -1. So again, is Pac-Man eating the bigger number? Yes. Yes, it is. So yes, because it's true that 1 is greater than -1. All right. So homework, here's your x, here's your y, here's your x, here's your y. Plug these two in and see if you get a true or a false statement. All right, that's it for page 26. Let's look at page 27. all of this I'm going to do, these are just notes. There are two types of lines that you will use when graphing inequalities. So what type of lines will these inequality symbols produce? So this is a less than or greater than. So does it have a little line on the bottom? No, it doesn't. So it could either, it's going to have a dotted line. So it could have a dotted line going this way, a dotted line going that way, a dotted line going this way, or a dotted line going that way. All right, but it's going to give me dotted lines or a dashed line. So this is dashed. All right. What about the second one? Now I do have a line on the bottom. That means I'm going to have a solid line. So I'm going to have a line going this way, or a line going that way, or a line going this way, or a line going that way. Again, solid lines. So that's us talking about the two types of lines we're going to have depending on which type of inequalities we get. Now, what about shading? So this is all about shading. So I'm going to use my highlighter to shade. So you will need to shade a region when graphing inequalities. Which region of the line should you shade? So both of these are going to be greater than. So that means that you're trying to color in or shade in the parts where it's going to go to infinitely many positive answers, because greater means positive. So if you have a line like this, you're going to be shading in this side. So that's up. This is the upper region for this side, for this type of equation. This is on top, and then this way. All right, but what if I wanted a less than? Less than means I'm going to infinitely to the negative infinity sign. So we're going to shade underneath. So everything that we did on the top, now we're going to do the opposite. So this shades on the bottom. This is now the bottom. This is the bottom. And then this is the bottom. Now, if I didn't know up and down, we can always plug in 0, 0 or any other point and see if that's part of our region. But again, these are just shading on if we're shading above or shading below the line, depending on if we have greater than or less than. So this is greater, greater, shade up, and this is less, so shade down. All right, so looking on page 28, I'm going to do the top. So this is me, Doc, and then you guys are going to do the bottom. So homework. All right, so let me zoom in a little bit. There you go. So is it in slope-intercept form? So graph the inequality. Is this in slope-intercept form? Yes. All right, so I'm going to write yes. What is my slope then? So looking at this, it's the number right in front of our x. So this is 3 over 1. What's our y-intercept? That's going to be a positive 1. Step 2, plot the y-intercept. That's this guy right here. So I'm going to go to my graph. Yep. Go to my graph, go up to 1, and plot my point. Part 3 says, from the y-intercept, graph the slope. So this means up, 1, 2, 3, 1 to the right. 1, 2, 3, 1 to the right. 1, 2, 3, 1 to the right. Or I can go backwards. 1, 2, 3, 1 to the left. Ooh, 1, 2, 3, 1 to the left. 1, 2, 1, 2, 3, 1 to the left. Then grab my ruler. There we go. Oh, I saved myself. What did I do wrong? I didn't check to see if it's dashed or solid before I connected my dots. So be careful, all right? I got lucky. It is a solid line. Why? Because it has this little line on the bottom, all right? So since it has a little line on the bottom, we do have a solid, but be careful. I almost made a mistake, so be careful. All right, I don't want to do this. What I would rather you guys do, I want you guys to plug in 0, 0. So I want to know, is this point right here, the 0, 0, is it part of my solution? So is 0 greater than or equal to 3 times 0 plus 1? Why am I putting this? Because I'm plugging in a 0 into my x and my y. All right, so plugging in a 0 into x and y. So that just means that this guy goes away. So is 0 less than or equal to 1? Is 0 less than 1? Yes. Is Pac-Man eating the bigger one? Yes. Okay. So that means that I am going to include my 0, so I'm going to shade in that side. All right? So this is a yes. And then that's it. So what are you guys going to do? You guys are going to do the same thing. Is it in slope-intercept form? What's your slope? What's your y-intercept? Plot your points, plot your y-intercept, plot your slope. Be careful, do not do what I did and connect my dots right away. Make sure, is it dashed or is it solid? And then, again, don't do this part, plug in 0, 0. Plug in 0, 0 and see, is it part of your solution, yes or no? If it's a yes, then shade in where the 0 is at. If it's a no, then shade the other side. All right? So you guys are also going to do page 29 and 30. So you guys are going to do example 5. I'm going to do this one. And then on page 30, you guys are going to do the rest. Okay? We are also not going to do this question. So we're not going to do example 7. So example 6, again, you're going to do example 5. So let's look at example 6. Is this in slope-intercept form? No. So let's get rid of stuff. So does this need to be here? No. So subtract 4x. This is fine. This needs to move. So subtract 2. It needs to go to this side. So I get negative y is less than or equal to negative 4x minus 2. However, I do have this negative, so I need to divide everything by a negative 1. However, for inequalities, when I divide by a negative 1, what happens? My sign is going to switch. So instead of a less than, now it's a greater than. Negative and negative gives me a positive x, 4x, and negative gives me a positive 2. All right, so now step 1 is done. We have y is greater than or equal to 4x plus 2. Identify my m and my b. My m is 4 over 1. My b is 2. Is it dashed or is it solid? Since I have the little line on the bottom, it's going to be a solid line. So let's shade everything, or let's plug everything in. So I start at 2. I'm going to go up 1, 2, 3, 4 over 1. 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 2, 3, 4 over 1. It is solid, so I am going to connect my dots. And then I'm going to see, is 0 greater than or equal to 2? Because this goes away, right? So 0 greater than 2. So looking at this, I'm eating the 0. It is not. So I'm not going to shade in where the 0 is at. So the 0 is right here. So I'm actually going to shade the other side. All right? So you guys would do the same thing on the other side. So this is a no. And do that. All right?